Hello, welcome. We are going to solve some of the review problems to help you better prepare for the test. So here we're doing problem number 10 where we have 6x cubed over 27x squared plus 12x. And basically what we're going to do is we're going to try to factor something from the bottom, from the denominator, and the number that goes into 27 and 12 is 3 and x. So if we divide 27x squared by 3x, we're going to get 9x, and 12x divided by 3x is 4. And on top, it just stays the same. And if you notice, 6 can be divided by 3, so you get equals 2. X cubed can be divided by x, so it would be x squared over 9x plus 4. There's nothing else that I can do, so it stays like that. And now we're going to do the domain. The domain is x belongs to all real numbers, such as that x. Now we take this denominator here, and we want to make sure that the denominator cannot equal 0. Now you can do this in your head, but if you want, you can do it inside the paper. Basically, this is saying that x must be different than 0, and over here x must be different than, we move the 4 to the other side, becomes negative 4, and we divide it by 9, so x must be different than negative 4 ninths. So we come over here and we write that as part of our domain. And there we go. So that is our domain for this problem. Okay. Now let's do number 11. Number 11 is x squared minus x minus 2 over 3x minus 6. Very good. So on this one, we're going to try to factor. So let's see. One number gives me 2. 2 would be 1 and 2. This would be 1 and 2. So I'm going to put 1 and 2 over here. This would be negative 2. This would be positive, because negative 2 plus 1 gives me negative 1. And negative 2 times 1 gives me negative 2. On the bottom, what can I factor from 3x and 6? Basically, I can factor out of 3. So this becomes x minus 2, because 3x divided by 3 is x, 6 divided by 3 is negative 2. Now that I have done my factoring, I look for anything that can cancel, and I notice that the x minus 2 can cancel, so I'm left with x plus 1 over 3. So that's my answer. Now I have to do my domain, which is x belongs to all real numbers, such as that x must be different than, I look at my factored denominator and I notice that x must be different than positive 2. Okay, basically, I'll come over here, sorry, to be 3x minus 2 must be different than 0, so x must be different than 2. Okay, and that's where we get this. Alright, so let's go on to the next problem. And get some paper here. Alright, so let's do problem number 12. Where we have negative x squared plus 16 over negative x squared minus 9x minus 20. Okay. Well, first thing I notice is that I have negatives in front of the x squared, and that's not good. So we're going to factor out the negative. Okay, so that becomes x squared minus 16. And I'm going to have factor this. So this would be x squared plus 9x minus positive 20. So basically when I factor the negative, everything inside changes the sign. Okay, well, notice what happens. The negative goes away. Okay, now for this guy right here, remember to add the 0x. Okay, so if I add the 0x, I'm looking for a number that gives me 16. So it'd be 1 and 16, 2 and 8, 4 and 4. Well, the one that I want that gives me 0 will be this one, so this would be x4, x4, and since the 0 is always positive, so it would be positive, and to give me a 0 it would have to be a negative. Over, now I want to do the same thing on the bottom. We want the number 20. So what numbers give me 20? 1 and 20, 2 and 10, 4 and 5, and that's it. Which one gives me 9? Will be 4 and 5. So we open parentheses, put the x, put the 4 and the 5. 9 is positive, so 5 will be positive, and 4 will be positive also. Alright, so we factor the top, we factor the bottom. Now what can we cancel? The x. Okay, so then this will be x minus 4 over x plus 5. Okay, so that's our answer. Now we need to do the domain. The domain will be x belongs to all real numbers, such as that x must be different. Now you need to focus on the denominator before it gets canceled. Okay, on the factor form, basically this is the denominator. It got changed to that, and then got changed to that. That's the factor form before it gets canceled. So basically x must be different than negative 4, and x must be different than negative 5. Okay, so the answer is that. Alright, let's try number 13 now. Will be 4xy to the third over 5x squared times 20 x to the third y to the second negative 16x y to the seventh. Okay. Basically, these are monomials, means they're only one term in each on the numerator and denominator. So basically, we cannot factor, but we can look if you can cancel anything. And I noticed from the beginning that I can cancel the 5, because 5 goes into 5 one time and 5 goes into 20 4 times. I also can cancel the 4 here that I just had with the 16, because 4 goes into 4 one time, 4 goes into negative 16, negative 4 times. So basically, I'm going to have 4 times 1 is 4 on top, and on the bottom, I'm going to have negative 4. Okay. And on top, I'm going to have x to the 4th, y to the 5th. And on the bottom, I have x to the 3rd, y to the 7th. How to get the third? 2 plus the invisible 1 equals 3. Alright, now if you notice, I can cancel the 4's. This would be 4 divided by negative 4 equals negative 1. So just put a negative there. The x4 and x3 can be divided. So 4 minus 3 will be 1. So, and the x stays on top because 4 is bigger than 3. And the y stays on the bottom because 7 is bigger than 5. And 7 minus 5 will be 2. Okay. And for these problems over here, the problem did not say to find the domain or find the undefined values for x. So we're good. We're done. Let's do number 14 now. And basically we'll start by trying to factor. Don't forget to add the 0x right there. So that means this will factor as x and x. What numbers give me 9? So you come to the side of your paper. 1 and 9, 3 and 3. Which one will give me 0? That will be 3 and 3. So it'll be 3 and 3. Sine of 3 will be positive, and this will have to be negative to give me the 0 that I want. And also negative 3 times positive 3 gives me negative 9. Alright, underneath I'm going to get, what can I factor from 2x and 10? The answer is 2. So this will be x plus 5 times x plus 5 on top and x minus 3 on the bottom. Alright, now that we have factored everybody, now we can start canceling. So this cancel, the x plus 5 cancels, the x plus 3 cancels, and you're left with x minus 3 over 2. And these problems we don't have to worry about the domain, so we're done. Let's go ahead and proceed for number 15. Number 15 is x minus 4 over 2x squared times x over x squared minus x minus 12. First thing I ask myself, can I do anything here on the top? No. Can I do anything on the bottom? No. Top? No. Here I can factor. So I'm looking for a number to give me 12. The number is 1 and 12, 2 and 6, 3 and 4. So which one is the one that's going to give me a 1? The answer is 3 and 4. Now what is the sign of the biggest? The sign of the biggest is the same as the middle term. So that means negative 4 plus 3 or minus 1 minus 3 gives me negative 1. And the answer is positive. So I'm going to rewrite what I have here. And x plus 3, x minus 4. Now we're looking for things that will cancel. Okay, we see the x minus 4 cancel, the x cancel with the x squared, and I believe that's it. So on top we cancel everybody, so we put a 1, and there's not going to be enough space here, so I'm going to write underneath here. So it's going to be a 1 on top, and on the bottom is going to be 2 times x plus 3 oh, and I forgot the x over here. So it'll be 2x times x plus 3. You can leave it like that, or you can write it as 2x squared plus 6x. Either one will be fine. Okay. Alright, let's go to the next problem. Problem number 16. If I'm moving too fast, you can always stop the video and go back and forth. Okay. So let's go ahead and do number 16 now. Is 3x cubed over 4x plus 4 divided by 9x over x plus 1. Basically, again, ask ourselves, can I factor anything? Can I do anything on the top over here? On the bottom, I can factor out a 4, so this would be x plus 1, because 4x divided by 4 is x, 4 divided by 4 is 1. Now remember, division of fraction means you're going to change to a times, and you're going to flip the second term. As you flip, check if you can factor anything. There's nothing I can factor from x plus 1, nor 9 times x. Now let's see if we can cancel anybody. Off the bat, I can cancel these. I can cancel the x cubed, it becomes an x squared. Cancel the 3. 3 goes into 3 one time, 3 goes into 9 3 times. Let's see, is there anything else I can cancel? Nope. So on top, I'm going to have x squared. On the bottom, I'm gonna have 4 times 3 is 12. And voila, that's my answer for number 16. Let's try number 17. It should be 12x cubed y to the 6 over 9xy divided by 6y squared over 3x. Basically, because these are monomials, you cannot do any factoring, so basically we're just going to copy the first term. Actually, as we copy, we notice that we can reduce this. So let's go ahead and reduce that. This will reduce by 3, so this becomes 4 and 3. So this will be 4 over 3. Also, the x will become x squared, and the y will become y to the 5th. Okay, let's change this to a times. And let's go ahead and flip the terms. So this will be 3x over 6y squared. Now let's go ahead and do the canceling. I see that the 3 will cancel with this 3. And 2 goes into 4 2 times, and 2 goes into 6 3 times. And let's see, y to the 5th, y to the 2nd. The y is going to stay on top, so it'll be y to the 3rd on top. So you can go ahead and cancel that and write y to the 3rd. I guess that's it. So now we're going to have 2. We have x squared times x is x cubed. Y to the 3rd. And on the bottom, everybody can cancel except for the 3, so we got a 3. And that's it. Let's go ahead and go for the next problem. We'll do problem number 18. So this would be x squared minus 16 over x squared plus 4x plus 3 divided by x minus 4 over x plus 1. Basically, again, remember, every time you see x squared with only 2 numbers there, or 2 terms, make sure you add the 0x. So that means this would be x and x, so it would be 4 and 4. Why 4 and 4? Because you go here and says, what number gives 16? 1 and 16, 2 and 8, 4 and 4. Which one gives me the 0? The 4 and 4. That's how I got the 4 and 4. Put the positive, because 0 is positive. So to get a 0, you need to have a negative 4. Alright. We have a 3 here, so numbers give me 3 is 1 and 3. So then this would be x, 1 and 3. Now I want a 4, so this would be a positive, so that means to get a 4 I need a positive 1. And let's change this to times. I'm going to flip this number. It will be x plus 1 on top, x minus 4 on top. So basically I factor the top, factor the bottom, change the times, I flip the second term. Now that I've done all that, I'm ready to start canceling. So this cancels with this, the x minus 4 cancels, and that's what I'm left with. X plus 4 over x plus 3. And that's my answer. Alright, problem 19 is about this common multiple. If you notice, what you're going to do is you're going to write the numbers. I mean, basically we're looking at 2 numbers. I'm looking at 6x to the 3rd y and 2x y squared, right? So basically, do the prime factorization of 6. Prime factorization is 2 times 3, and 2 is a prime number, so it's okay. So now let's line up the numbers. Line up the first number, so which would be 2 times 3 times x to the 3rd times y. Then line up the second number, which would be 2 to the first. I don't have a 3, I do have an x, and I do have a y squared. Now let's do the LCM. The LCM then will be 2 times 3. Which one is the highest exponent? X to the third. And which one is the highest exponent? Y to the second. So that means the LCM will be 6 x to the third, y to the second. Okay. And let's go ahead and do number 20 over here, which is x squared plus 5x and x squared minus 25. So here, let's factor it. So this will be x plus 5. Right? And let's go ahead and factor this guy, remembering that to add the 0x over here. So that means this would be x plus 5, plus 5 minus 5. So once I factor, I line them up. This would be x plus 5 for the first one. Second one I line up. This would be x plus 5 and x minus 5. So when I do the LCM, my LCM will be x plus 5, x minus 5. So that's my LCM for this one. Oops. Alright, let's go to the next one. Problem number 21. X squared minus 3x minus 18 and x squared minus 5x minus 6. If I do the factoring, first I look at for number 18, the 1 and 18, 2 and 9, 3 and 6. Which one gives me the 3? It'll be the 3 and 6. So 6 will be negative and the 3 will be positive. And if I do this one right here, looking for 6, so it'll be 1 and 6, 2 and 3, and that's it. Now if you notice, both of them give me 5, so I need to check the signs. This would be a negative, and this would be a positive. This would be a negative and a negative. So now both will give me negative 5. Final check is the multiplication. Negative times a negative gives me a positive, and this is a negative, so I know that's not the one. The negative times a positive gives you a negative, so I know that's what's going to work for me. So I put those numbers there. So now I'm ready to do my LCM. I copy the first term, which is x plus 3, x minus 6, and the second term, which is x minus 6 and x plus 1. So my LCM will be x plus 3, x minus 6, x plus 1. And that's my answer right there. Now let's do number 22. 22 is adding, subtracting fractions. We're going to have x plus 9 over 2x plus 1 plus 3x plus 6 over 2x plus 1. Alright, when adding, subtracting fractions, we're looking for a common denominator, and on this one, we're very glad to see that we already have a common denominator. So basically, we just have to combine my terms. So basically, what can I combine? The x with the 3x will be 4x, and the 9 plus 6 will be 15, and this would be 2x plus 1. And with adding subtracting, you do need to find the domain. So the domain is going to be x belongs to all real numbers such as that x. Now to find the restriction, what you need to look at is at your common denominator, which is right there, and we want to set the common denominator to different than 0. So basically x must be different than negative 1/2. So we'll come over here and we'll write that x must be different than negative 1/2, and that's our answer for number 21 too. Alright, for number 23, so let's go ahead and go for number 23. So we have 23. 23 is 2x plus 3 plus 4x over x squared minus 9. First of all, add the 0x there. So we know that this is going to be x plus 3 x minus 3. So I'm going to have x plus 3 over 3 plus 4x x plus 3 x minus 3. Let's do the LCM. We'll do the first denominator, which is x plus 3. We'll line up the second denominator, which has x plus 3, but also has x minus 3. So our LCM will be x plus 3, x minus 3. So I'm going to copy the first term, and I'm going to ask what is missing from my denominator that's on the LCM. If you notice, it's missing the x minus 3. So that means I'm going to multiply top and bottom by the x minus 3. And I'll go ahead and copy the second term, which is 4x, x plus 3, x minus 3. Now the good thing now is that we have a common denominator. This denominator is the same as this one. So we can write everything under the same denominator, which is x plus 3, x minus 3. And on top, I'm going to multiply, so it's going to have 3x minus 9 plus 4x. And when we add that, we're going to get 7x minus 9 over. And to finalize it, we need to FOIL this, so this would be x times x is x squared. Negative 3 plus 3 is 0x, so I don't have to write it. And the last term is going to be 3 times negative 3, which is negative 9. Alright, for my domain is x belongs to all real numbers, such as, then use your LCM right here. X must be different than negative 3. X must be different than positive 3. So we can write over here, x different than positive negative 3. And voila. Whoops, can I see the thing? There we go. Okay, so that's your answer right there. Okay, let's do number 24 now. Basically, I'm going to factor the denominator. So we're looking for number 8. And what numbers give me 8? 1 and 8, 2 and 4, and that's it. So I'm going to write x and x, 2 and 4. 4 is positive, 2 is also positive. And let's do the other one, which is 16. So numbers give me 16, 1 and 16, 2 and 8, 4 and 4. So 2 and 8 gives me 6, which is the number in the middle. this would be x2, x8. Sine of 8 is be negative, sine of 2 will be positive. Okay, so first step is to factor them. Once you factor, you're going to do your LCM on the side. So you're going to write the first term, which is x plus 2, x plus 4. You're going to do your second term, which is x plus 2. I don't have an x plus 4, but I do have an x minus 8. So right here on the sign. So that means my LCM is going to be x plus 2, x plus 4, x minus 8. So with that in mind, I come over here, I copy my first term, which is x plus 2, x plus 4. And I ask myself, what is missing from my denominator when I compare with my LCM? The answer is missing the x minus 8. So that's what I multiply top and bottom by. Once I've done that, copy the second term. Now compare my denominator with my LCM, and what is missing? The x plus 4. Alright, so that means my common denominator will be x plus 2, x plus 4, x minus 8. And on top, I'm going to have 1 times x is x, 1 times negative 8 is negative 8, and 1 times x is 1x, 1 times 4 is 4. Okay. On the top here, I'm just going to combine like terms, so I'm going to have x plus x equals 2x minus 4. On the bottom, what I'm going to do is FOIL. So this would be x squared, 2 plus 4 is 6x. That's giving me my middle term. And my last term is 2 times 4, which is positive 8. And then here I have x minus 8. Alright, so now I'm going to FOIL again. What I do is I multiply each term by each member on the second parenthesis. So this would be x squared times x is x cubed. X squared times negative 8 is negative 8x squared. Then positive 6x plus x is positive 6x squared. 6x times negative 8 is negative 48x. 8 times x is positive 8x. And 8 times negative 8 is negative 64. Okay, we run out of space. There we go. Okay, so final step here is to combine like terms. So I have x cubed, and combine these two, I'm going to get negative 2x squared. Combine these two, I get negative 40x, and bring down the next 64. So that's my final answer. And we still need to do our domain, so let's go ahead and do a domain. X belongs to all real numbers, such as that x. All you need to do is look at the LCM, and then x is different than negative 2. X must be different than negative 4. And x must be different than positive 8. And voila! That's our answer for problem number 24. Okay, now we're ready for problem number 25. Alright, problem 25 had to do with subtraction of fractions. And the cool thing about 25 is that we have a common denominator already to begin with. So it's pretty easy. but you do need to be careful with your sign. So let's see what happens here. That's our problem. So notice we have a common denominator, so I'm going to go ahead and write it under the same denominator. This would be x minus 6. The one area we need to worry about is that the negative is applied to each one of them. So it becomes negative 8x, negative 7. Okay, combine like terms, negative 8 plus x is negative 7x. Negative 6 minus 7 is negative 13. And then x plus 5. Okay, and we need to go to domain. Domain is x belongs to all real numbers, such as the x must be different than the denominator. The common denominator, x must be different than negative 5. And voila, that's your answer. Alright, let's do number 26, which is x over x plus 1 minus 3 x plus 4. Let's do our LCM since there's no factoring to be done. So we're going to get the first term, I have x plus 1. Second term, I don't have an x plus 1 because I have an x plus 4. So that means for my LCM, I'm going to have x plus 1, x plus 4. So, now that I have my LCM, come over here, copy the first term. Ask yourself, looking at this denominator, what is missing from my LCM? What's missing is x plus 4 over x plus 4. Copy the second term. Look at the denominator and say, what is missing? Well, it's missing the x plus 1 over the x plus 1. So, now we have a common denominator, which is x plus 1, x plus 4. And when I multiply this, guys, this is going to be x squared plus 4x minus 3x minus 3. So combine like terms, you're going to get x squared plus x minus 3. And on the bottom, be x and x is x squared. 1 plus 4 is 5x, and 1 times 4 is positive 4. And that's it. Well, forgot about the domain. X belongs to all real numbers, such as, look at the LCM, x must be different than -1, and x must be different than 4. Now we're ready to go to problem number 27. Problem 27 is 7 over x minus 9 minus 2x minus 6 over x squared minus 13x plus 36. And first of all, let's factor this. This would be 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. We'll look at this list of numbers and looking for number 13. Should be 4 and 9. This would be x4, x9. Sign in the middle is negative, so that means the biggest digits will be negative. Negative 9 minus 4 is the one that gives me negative 4, negative 13. Alright, now I'm ready for my LCM, which is first term is x minus 9, second term is x minus 9, x minus 4. So that means my LCM is x minus 9, x minus 4. So with that in mind, I'm going to copy the first term and ask myself what is missing from the denominator when I look at the LCM. And the answer is missing the x minus 4. So we write that down, top and bottom. Copy the second term and ask the same question again. Is there anything missing from the denominator when you compare with the LCM? And the answer is no. So that means I don't mess with this guy. So if you notice now you have the same denominators. So you have a common denominator which you write only once. And on top you distribute. So you're going to get 7x minus 28. Now this is important. Negative. Okay. Negative 2x. Positive 6. Alright. So now I'm going to combine like terms. So we're going to get 5x minus 22 over x times x is x squared. Negative 9 times negative 4 is negative 13x. Negative 9 times negative 4 is positive 36. So that's our final answer. We didn't need to do the domain, which is domain is x belongs to all real numbers, such as that x must be different. Look at the LCM, 9 and x is different than 4. And that's your answer. Alright, we have 3 more problems to go. So let's do problem number 28. Problem number 28 is (3x over 3x plus 21 all over 9x squared over x plus 7. There's no addition here, so basically you can go ahead and start with writing this as a division. Right? So this here on top divided by the bottom. Now I'm going to change the division 2 times. But first make sure you copy the first term as it is. Change the division 2 times. And you flip the second term. I notice here too that I can factor out of 3. I've done that before, but I forgot. I'm doing that. And then x plus 7 and x plus. Okay, now I factor everybody. I'm ready to cancel. So we're going to cancel the x plus 7. I'm going to cancel these 3's. I'm going to cancel this x with the x squared, so this becomes x. That means on top, I cancel everybody, so I'm left with a 1. On the bottom, I should have a 9 and an x, so it'll be 9x. And voila. And the cool thing about this is you don't have to worry about the domain. So we're done. Now remember, if there was addition of fractions over here, you need to add the fractions or subtract, just like we did on assignment 11.7. Okay, so you might want to review that too for your test. Okay, let's go on the next one. We only have 2 more problems. Alright, 29. We have x over x minus 1 all over 10x squared over negative 4x plus 4. Alright. Okay, so we have x over x minus 1 divided by 3x squared. And notice I can factor this guy here, so I'm going to go ahead and factor the negative 4, so it'll be x minus 1. Alright, division, we copy the first term, change it to times, flip the second term, and now let's look for something that cancels. X minus 1 can cancel, dx can cancel dx squared, left with x. Let's see, 2 goes into 4 2 times, and 2 goes into 10 5 times. So on top I'm left with a negative and a 2. On the bottom I'm left with 5x. Cool, huh? And number 30, last problem of the review. 1 over x minus 2 divided by x plus 3 over x squared minus 4. So I'm going to copy the first term divided by alright, let's put a 0 there, right? So this would be x 2 and 2 positive and negative. So this is x squared plus 0x minus 4. I broke it down to 2, right? Positive and negative. And that's how I got that. And I'm going to copy the first term, change it to times, flip the second term. Alright, now look for something to cancel. It does. So my final answer is x plus 2 over x plus 2. Now let's do the warm-up problems, because these type of problems will also be on the test. Let's suppose I have these problems right here with radicals. Anything, first thing, make sure that what the radicals is by itself. Then put parentheses on both sides and raise to the same number that is inside the radical right there. So this is the 5th root, so we're going to raise to the 5th power. This cancels. We're left with x plus 4 equals 3x minus 2. And we have a very simple equation where we can solve. So this would be x minus 3x equals negative 2 minus 4. This would be negative 2x equals negative 6 divided by negative 2. X equals positive 3. Now remember that you need to check if your answer is valid. So go ahead and check. How we do that? We started out with our original equation, which is this, and we plug it in the answer we got to see if it's a valid answer. So I'll put it in the 3 there, and basically we're looking to see if this side is going to be the same as that. So this will be 3 times 3 minus 2. So on this side I get the 5th root of square root, the 5th root of 7, and on this side, let's see what we get. 3 times 3 is 9, 9 minus 2 is 7. So this is valid. In other words, the answer is 3. The answer 3 is a valid answer. Okay? Which is x plus 6 minus x equals 4. First thing I'm going to do is get the radical by itself by moving the x. So this will be the square root of x plus 6 equals x plus 4. Now I'm going to raise to both sides to the square. That cancels. You're left with x plus 6. And here you're left with x plus 4 times x times 4. So now you can use the FOIL trick that we taught. X plus 6, x times x is x squared, 4 plus 4 is 8x, and 4 times 4 is 16. Get one side to be 0, so this would be x squared plus 8x plus 16 minus x minus 6. I'm going to combine like terms, so it would be 0, x squared plus 7x plus 10. Now we're looking for a number that gives me 10, so it would be 1 and 10, 2 and 5, and the 6. So which one gives me 7? 2 and 5. So this would be x2, x5. What is the sign of 5? Positive. So that means 2 will also be positive. So my final answers are x equals -2, and x equals -5. Good. But now we need to make sure we check the answers. Okay. So let's use this. X plus 6 minus x equals 4. Instead of x, we're going to use -2. -2 plus 6 minus 2 is equal to 4. Let's take a look. This would be the square root of 4 plus 2. Question is equal to 4. This would be 2 plus 2 is equal to 4. Yes. So that means this answer is valid. Let's try the other one. We have x plus 6 minus x equals 4. So we're going to plug it in the -5 plus 6 minus 5 is equal to 4. This would be the square root of 1 plus 5 equals 4. And put a question mark there. So this would be 1 plus 5 equals 4. And the answer is no. It's not the answer. Basically, then our answer for this problem is x minus 2, x minus 5 is not valid. Okay, and this concludes the review for the test. I hope that this was helpful, and good luck in your test. Have a good day.